So this is our air conditioning column, right? It is A times C. So you should have, and did you end up having this equation here, 5x squared minus 11x minus 36 equals 0? So that 180 comes from, our A value is this 5. So maybe I'll write that in red. Our A value is always the one that's in front of the x squared. Our B value, you said you already know, is that negative 11, right? And that C value is going to be that negative 36. It's kind of nice because it's in alphabetical order if you do it right. So you're going to literally take 5 times negative 36. And that is your A times C. That comes up with that negative 180. All right, then it's just basically check, divide a whole bunch. Especially when it's big like 180, sometimes it's just like, just try a bunch of different things. Okay. Are you good from there, you think? Or, yeah? Awesome. Remember, you should have a method. You should have a method on how to factor, and guess and check is not going to be the one that saves you all of the time. So if you're struggling with factoring, just come see me. We can work on stuff. There's also tons of stuff online if you don't want to come talk to me. All right? Other questions? Yeah. You solved it?
Yep.
How do you do that all the time? Emza.
On number 38, I got to the part where I had 3 times x squared plus negative 5x plus x plus negative 6 equals 0.
Say that again. Where'd you get to?
So it's 3, and then in parentheses it has x squared
Minus.
negative 6x plus x plus negative 6.
It should have been minus 5x minus 6. Oh, you were factoring, right?
Yeah.
So can I see where you were? Today's lesson is basically the backbone of what you're going to be doing moving on. It's going to be a lot of this. So make sure you take the time and you understand what's happening. All right, we're talking about similar polygons. Similar polygon is one that has the same shape but not necessarily the same size. And I think the best way to think about it is, if you'd have this shape and you took a magnifying glass to it, it just makes it bigger, but everything stays proportional. And all the angles look the same. So that's what's basically happening here. I'm taking a magnifying glass and just making it bigger. Or if you're on the copy machine and you hit twice as big and you just come up with a bigger picture. They're the same, they're just bigger or smaller. Well, we got some rules to determine if they are similar without, measuring everything. So 2 polygons are going to be similar. If their corresponding angles are congruent. So if we look down below, every angle has to have a congruent angle on the other shape. And these are going to be known as your corresponding angles. Well, if you look here, A is congruent to W, B is congruent to X, C is congruent to Y, and D is congruent to Z. So remember what congruent means with angles. If A is 41 degrees, I immediately know that W is 41 degrees. If B is 92 degrees, that automatically means X is 92 degrees. That has to be true for them to be similar. So that's the first thing. You have to check to make sure all angles have a congruent corresponding angle. Also remember, this could be turned. So you might actually have to figure out which ones need to be congruent or are corresponding. It's nice when it's perfect like this, but sometimes it'll be turned and you'll have to find it on your own. The next thing is the lengths of the corresponding sides are going to be proportional. Remember what proportional means. It might look something like 1/2 equals, 11 over 22. Those are proportional because if I simplified it, it'd be 1/2 equals 1/2. That's what makes it proportional. To be proportional, it is a proportion that is true. The symbol, it's a little tilde, tells you 2 shapes are similar. All right, what we're going to do next, and we're not going to do it a lot because most of the time I'm going to say two shapes are similar and you have to pull information from that fact. We are going to double check to make sure these two shapes are similar. The first check we're going to do is we're going to make sure all the angles have a corresponding angle that is congruent to it, which I already did in words. Let's just put it in writing. So angle A has to have one it corresponds to or is congruent to on the other shape. Well, it does. It's got W. So we can say our first angle is good. We have angle A is congruent to angle W. And we can do the same thing for all the other angles. We can say angle B has a corresponding angle because it is congruent to angle X. We can also say angle C has a congruent angle because it is congruent to angle Y. And finally, angle D has a corresponding angle because it is congruent to angle Z. So far, so good. Everything checks out there. We're good. Every angle has a corresponding angle that it's congruent to. That is our first check. Our next check is to make sure all the lengths are proportional. In order to do that, we have to put corresponding lengths on top of each other in a ratio. Because to have a proportion, you have to have a bunch of ratios. So my second check is comparing corresponding sides. So it's almost like when we had two congruent angles, or two congruent triangles. The one that goes from A to B, since those two are our congruent angles, this side is going to correspond to this side. All right? They're basically the zoomed in version of that side. So AB is going to correspond to XW. And how I'm going to write it right now, I'm going to write it as a fraction. I'm going to put WX over AB. Yes, Samsa?
You can do that the other way around.
I could do it the other way around, and I'm going to talk about that in just a second. Because you bring up a good point, right? Ratios have a very specific order. If we did men to women in this class versus women to men in this class, we'd have two different ratios. They'd be flipped. So as soon as I pick this WX to be on top, I am going to, and you're going to see what I mean later on, I'm going to call this my top. And I'm going to call the other one the bottom. And that is because any fraction I come up with these, anything I pull from here has to be on the top of the fraction. Anything I pull from here has to be on the bottom of the fraction. So it's important for you to recognize which is your top and which is your bottom. The easiest way is just label it top and bottom and just keep looking at it when you're doing the problem. All right, so we have WX over AB. Our next corresponding set of sides is XY and BC. So we're going to put a little equal sign. And we're going to put XY over BC. That's what it means to be proportional. These two things have to be equal to. Would it have been okay if I flipped this? No, because I already picked these to be the top. WX came from my top shape. XY came from my top shape. My next corresponding sides are going to come from the top shape. So that's going to be this ZY over DC. And finally, we're going to do that ZW over DA.
Is it okay if we did AB over WC?
No. Like I said, this has to be your top. That's why you should have a top here. Anything that comes from this needs to be on the top of your fraction. Anything that's here goes to your bottom of your fraction. Otherwise, if I ask for boys to girl ratio and you give me girls to guys, I don't know. It's wrong because you're giving me the wrong order. They all have to be in the same order. All of these were on the top, from the top shape, and all of these were from the bottom shape. Yes?
Do you have to draw them in the same
No. Nope. But, Grant, no matter what order you have them, they all have to equal each other in order for this to be similar shapes. So this has to be true for them to be similar shapes. So now we have numbers to put to those letters. So let's go ahead and do that. Well, WX is 5 over AB, which is 15. That has to be the same as XY. Well, XY is 4 over BC, which is 12, which has to equal my YZ, which is 7 over 21, which has to equal 6 over 18. Right now, they might not look like they're equal. So that means you're just going to simplify them. Are you going to reduce those fractions? Well, 5 over 15, well, you can divide 5 by 5, and you can divide 15 by 5, so we can reduce that to being 1 over 3. 4 over 12 simplifies to 1 over 3. 7 over 21 simplifies to 1 over 3. And finally, 6 over 18 simplifies to 1 over 3. Are all those equal? Then you are good. They're all proportional. So that means this shape is in fact similar because all those are equal. Now, here is where if you make a mistake, you mess everything up. If you would have flipped any one of these by accident, you would have came up with one of these being 3 over 1. And you'd think, well, they're not proportional. That's why it's imperative. Everyone pay attention to this. Easiest way to get these right is to call one shape your top and one shape your bottom. That way you know on the top of the fraction, I'm pulling stuff from here, and the stuff in the bottom fraction goes from there. The people that make the most mistakes on the test are those that don't care or take the time to know which one goes on the top of the fraction and which one goes on the bottom. And they mix everything up. All right, so take that time to do it correctly. All right, now that we know they're similar, let's go ahead and write that they're similar. So to write that they're similar, we have to put A, B, C, D. Remember when we said two triangles are congruent? The first one didn't matter how I wrote it. I can write triangle ABC or BCD. But it really mattered what order the second one in, right? You had to make sure that the sides were congruent and stuff and the angles. Same thing here. If I say ABCD is similar to, I now have to list the next shape in that exact same order with corresponding angles. So A was congruent to W, so my next has to start with W. B went with X, so it has to be X. And C went with Y, so it has to be Y. And finally Z. So order matters when writing a similar statement. It's just like writing congruent triangles or congruent polygons. It mattered which order they're in. It matters again with the similar. Are we okay so far? Okay. I think this stuff makes a lot more sense when we're actually using it in a problem. We'll just get to it in just a second. The next thing we're going to talk about is scale factor. That is the ratio of the lengths of the corresponding sides of two similar triangles. We already found the scale factor of the one up here. Anyone want to take a guess at what the scale factor is for this one? Yeah. You're close. 1 over 3. That's our scale factor of this one. Every side here compared to that side is going to be 1 to 3. That is our scale factor. So that's what I mean by the ratio of the lengths of the corresponding sides. So to figure out which are our corresponding angles and sides, sometimes you have to read what is being told to you. This says triangle ABC is similar to X, Y, and Z. We get two huge chunks of information from that. We get that angle A is congruent to, let's write bigger than that. Angle A is congruent to angle X because of the order they're written in. We have angle B is congruent to angle Y. And finally, we have angle C is congruent to angle Z. So let's go ahead and mark that on the shape. A is congruent to X. We'll put one tick mark on A and X. B is congruent to, what did I say? Y. So we'll put 2 on C, 2 on Y. And finally, B is to Z. Wait, I messed something up. I think I put the marks in. What did I say? Did I say the wrong thing? Did I B. Oh, I put them in the wrong spots. Yep, you were right. I was like, that doesn't match up right. Because I said B goes to Y. I was zoomed in a little too far. There we go. All right, there we go. All right, now that I know which angles correspond to each other, we can then notice which sides correspond to each other. So one way to do that is to, kind of picture this flipped and matching up to this scale. So this 6 and this 3 would be our corresponding sides. The other way you can do that is based upon how it's written. It goes A to B first, and this goes X to Y first. So that means AB corresponds to XY. It means that BC corresponds to YZ. And it means that CA corresponds to ZX. So that's some more information that you can pull from this. That AB corresponds to XY based upon how that's written. We know BC corresponds to YZ. And finally, we know that CA corresponds to ZX. So now it says get the scale factor of triangle ABC to triangle XYZ. We just have to find two sides that correspond to each other and have numbers attached to it, and that is going to be your scale factor. Well, if we look at that, we have AB and XY corresponding to each other. So if I wanted to find a scale factor of ABC to XYZ, that makes my ABC my top. So we do something like AB over XY, which is my bottom, which is going to equal 6 over 3, which is then going to equal 2 over 1. And we're going to leave it as 2 over 1, not simplify it to 2. We'll just leave it as 2 over 1. This one says go the opposite direction. What's the scale factor of your small to your big? You're just going to flip it. You're going to flip it to XY over AB, which is then going to equal 3 over 6, which is then going to equal 1 over 2. Those are our scale factors. And that's going to be the most important part of this unit, is getting scale factors and understanding what they do. All right, let's do an example with all this to make it all kind of gel a little bit more. So the polygons below are similar. Find the scale factor of the smaller triangle to the larger one and solve for the missing side and angle. When I read a question like this, what I'm going to do first is the angle. The angle requires almost no math. It just takes your knowledge of what similar means. Well, to be similar, all of their angles must have a corresponding congruent angle on the other one. So if we look at 42 degrees, that matches up with that 42 degrees on the other side. This 58 matches up with the 58 over here. So that means this 80 degrees has to match up with that A, that angle A. So we can jump right at the answer and say, well, the measure of angle A equals 80 degrees, and boom, I have a point on a test. It is honestly just reading from one shape to other, knowing that all the angles are congruent. The harder part is finding that missing side. Well, before you find that missing side, you have to find a scale factor. So let's go ahead and do the scale factor first. All right, when I'm doing a scale factor, we have a fraction, we have something on top and something on the bottom. In this case, they tell us what needs to be on the bottom, what needs to be on the bottom. It says the smaller triangle to the larger triangle. So our smaller triangle is going to be the top of all our fractions, and the larger triangle is going to be the bottom of our fractions. Does someone want to take a shot at what? We'll get the shadow in. Yeah.
It'd be 14 over 35.
It'd be 14 over 35. Would 16 over 40 work too?
Yeah.
Yeah.
Which should be 2.
So we're going to do 14 over 35 But if you did 16 over 40, you'd come up with the exact same simplified fraction. So our scale factor is going to be 14 over 35, which equals 2 over 5. Yeah.
So do you know which lines to use by which angles they fit between?
Mm-hmm. Kind of like remember we were comparing, we're seeing if two triangles were congruent, we'd look at that side that matched up with two angles that we know are congruent. Yep, just like that. Just like that. And just a reminder, 16 over 40 would have worked. So you could put a little note to yourself saying 16 over 40 would have done the exact same thing. All right, so our scale factor is 2 over 5. I'm missing this b. But I know it corresponds to that 25. So we need to set up a ratio with b and 25. So we'll have b over 25. Well, b over 25 has to equal that. Yeah, Ishan. Go ahead. Oh, you have the whole answer. Okay, gotcha. Well, I'm going to say this equals our scale factor, which is 2 over 5. Then we use our means extremes, or cross multiplication, which leads us to 5 times b equals 50, which makes b equals, which we already knew, 10. Cece.
Can you just do 2/5 of 25?
Mm-hmm.
So you wouldn't need to do the proportion part to get full points on test?
No. No, it's just the best way to set up is so sure to miss. So there are going to be problems where you need proportions because you'll have like 2 of these variables missing and you have to do the cross multiplication to get like x squared equals some number. So you should know how to do this, and you should probably have this method in your notes. So if you have to fall back on it and you don't know, sometimes you just know part of the scale factor and you need to use the multiplication. So it's good to know. Do you have to get full points? No, just make sure you are correct. Because what I see a lot of times, people shortcut it, and then on the test, I don't know what they did wrong, and then you kind of lose more points. But as long as you tell me it's 2/5 times this, then I know your math. Cam, do you still have a question?
No, I do.
Okay. All right, next thing we're talking about is perimeter. If two polygons are similar, then their perimeters are proportional to the scale factor. Cool. So that means if I have to find the perimeter of one object, I know the perimeter of the other, I can just use that scale factor to figure out the perimeter of that one. So that's what the problem we have set up here. We have A, B, C, D, E is similar to F, G, H, J, K, and I'm supposed to find the perimeter of the smaller one. Problem is the smaller one, I only know one side. I only know one side. So that means I need to start off by finding a scale factor. Does someone want to tell me what the scale factor is on these? Not simplified, just give me the fraction not simplified. I'll give you a second. Someone from this half. That half's doing a whole load. Yeah. 1/5?
Yeah.
I don't think 1/5. What fraction did you start with? 10 over 15. Yeah, let's just start there.
Okay.
10 over 15. That's perfect. That is correct. I think just your simplification was a little off.
Yep, it's 2/3.
It is 2/3. Yep. Just so you guys know, if you're in a bind and you're not sure how to simplify something, you don't have to simplify this. Because you can do 10 over 15, it just makes a bigger problem later on. All right, so we have 2/3 is our scale factor. Well, I also need to know, yeah.
Would 15 over 10 work, or would that proportion work?
Would 15 over 10 work? Yes. So as soon as she said it's 10 over 15, that makes this one the top and this one the bottom, right? If you wrote 15 over 10, just make sure you swap these words. And you can do it throughout this and see that you come up with the exact same answer I do. All right, so how you name it here tells you how you're supposed to say top and bottom over here. So this one now says top because Carly said we're using 10 first, and this one has to be the bottom. All right, we now know our scale factor. That means I need to know the perimeter of one of these guys. What is the perimeter of that large shape? Ishana.
69.
It is 69. And remember, that is the bottom of my fraction. So the perimeter of the small one, I'm going to call it P. So the perimeter of the small one over 69, because I said the small one's going to be our top, has to equal 2 over 3. So Hamza, if you're doing the reverse order, you should have 69 over P equals 3 over 2. Once again, we use our means extremes, or our cross product, and we're going to end up with 3P equals 140, 138. That's 139 though. 138. So what is our perimeter equal? What did you come up with, Isabel?
156.
56? You sure?
Yeah.
Well, my problem. So we have to have 138 divided by 3, right?
Oh.
3 times 5 is already 150. That's going to be too big. That's going to be too big. Yeah.
46.
46?
Yeah.
I think 46 is a little... Do you see it was a little too big?
Yeah.
Yep. Good news is, on the test, you can use a calculator. So our perimeter equals 46, and that is done. All right, questions on any of those? Yeah,
Could you possibly do the perimeter and multiply it by 2/3?
absolutely. Yep. That is exactly what Cece was asking, because if you realize that thing, you can just multiply it by 2/3 and you get that value. But I was saying, on the test, make sure you show me, I mean, you're not going to be taking my test, but for everyone out there, make sure you show me all those steps. The problem is so many of you just know what to do. You just plug in your calculator. And if you make the smallest mistake, I can't see it because you just have an answer down. So make sure you show me it's at 2/3 times that 69. All right. All right, one more problem we have to do. First thing we need to do is we need to come up with a scale factor. Can someone tell me a scale factor of these two shapes? Not simplified, just leave the fractions as is. Yeah. 2 over 3. That is simplified, but that's okay. So we're looking at 20 over 30, right? Which that's how you got your 2 over 3 from, right? Yep. So where did I get that 20 from? I got it from here. I put it on the top of the fraction. So I'm going to name this one top. That's the top dog. And then I'm going to name this one the bottom. Try to find x, y, and z. I'll give you a couple minutes. I'll give you a couple minutes to find x, y, and z, or I should say solve for x, y, and z. And then we'll do it all together. 9 minutes left, and I want to make sure I get to this graphing boohickey. All right, so I'm looking at x, and that matches up with the 21. That's that corresponding side. X comes from the top, 21 comes from the bottom, so I'm going to do x over 21 equals my scale factor, which is 2 over 3. Well, using the means extremes, or cross multiplying, however you call it, we are going to have 3x equals that 42. So that gives us x equals 14. The slightly different part is that y corresponds with 8. But 8 is from my top shape. So we need to have 8 first. Over y is going to equal my scale factor, 2 over 3. Means extremes, we'll have 2y equals 24. So y is going to equal 12. And finally, z corresponds with 10. 10 comes from my top, so I'm going to make that the top. Over z equals 2 over 3. And then we're going to have 2z equals 30. In other words, z equals 15. Any questions on any one of those? We're good? We're happy? Go lucky? Or at least we're something? We're surviving? All right. Brent, did you have a question?
No.
Oh, okay. You pulled it down too quick. All right. So our next one says we are supposed to plot the given points to draw quadrilateral A, B, C, D. And we're supposed to plot the points A prime and B prime, which is going to be part of a new shape. And that new shape has to be similar to our A, B, C, and D. So let's start off by just plotting A, B, C, and D. On your homework, this is much better marked, but these are all 1s. Super tiny, there's a 5 there, this is really smudged on your sheet. But each of those units is 1. All right, so we're going to plot the point 0, 0 for A. So plot 0, 0 and call that guy A. B is 4, 0. 1, 2, 3, 4, 0 is B. Our C is 2, 4. Up over 2, up 1, 2, 3, 4. That is that C guy. And finally, our D is 0, 2. And that is A, B, C, D. That is my shape. All right, then we have A prime and B prime. That just means we're making a similar shape. So I can delineate between A and A prime. So we have A is negative 10, negative 2, so that's down here. That is my A prime. That corresponds with angle A then. B is negative 2, 2, negative 2, negative 2. That is my B prime. Let's connect those 2 points. And note, this new shape has to be similar to this shape. But just looking at A to B is a lot longer on this one. So that means this shape should be bigger than this shape. And what we're going to do is we're going to use the scale factor based upon this compared to the length I know over here that it corresponds to. So A to B in our original shape was 4 units long. Make that red. A prime to B prime is now 1, 2, 3, 4, 5, 6, 7, 8 units long. That means this shape is exactly twice the size of this one, which means each element from this shape must be twice as big over here. So we're just going to look at lengths. So let's look at the next length that's pretty much straight up and down. That is from A to D. A to D is just 2 units. Well, since this is twice as big, this is going to go up 4 units. All right, so I count up 1, 2, 3, 4, and that is going to be the D prime. So 1, 2, 3, 4, that is going to be my D prime. And so that must be up 4 units. And let's go back to red. It's a little more tricky when you have kind of a slant to it. But the good news is we still have rise over run. We have rise over run. So if I just kind of have a dashed, let's see if we can make this work. I'm going to make a little dashed line saying I'm counting up and over. To get from D to C, we go up 2, over 2. Well, that means to get from D prime to C prime, I'm going to go up 4, over 4. So we're just going to go up 4, and then over 4. So that's up 4, over 4. And that is going to be my C prime, and now we can connect them. Another way you could have found C, you could have went up 1, 2, 3, 4 over 2, and then went up 8 over 4. Another way you could have done it is you could have said, well, from the midpoint here, you go up 1, 2, 3, 4. So from the midpoint here, you go up 1, 2, 3, 4, 5, 6, 7, 8. All the scales match. Just find a scale that's basically straight lines and make sure it matches. Now we know this shape is similar to that shape. Yeah, Cam.
So is the bigger one just like double the small one?
It is. It's exactly double it. But you're not going to know that till you start drawing. All right. Sometimes it might be 3 times as big. It might be 1.5 times as big, and you have to do the 1.5 kind of thing. There's one in your homework where this shape is turned compared to this shape. So you kind of have to picture what matches up, what corresponds, and what lengths you have to have. All right. Any questions for me on any of this? Okay, tomorrow we're going to talk about similar triangles that have some rules applied to them. But realistically, if you kind of understand the scale factor and how to find missing stuff, That is kind of the core of this section. Okay? And I do want to remind you there is a test not next Monday, but the Monday after. So that really means next Wednesday is probably our last actual lesson in this class for this whole mark period. What that means to you, right now is a great time to start organizing your notes. If you took any of your notes out of your binder, track them down, make sure they're in the proper order so you are ready to study when we hit the ground running on that study week. Not that you're like, Mr. Pabian, how do I do this? And I say use your notes, and you're like, oh, I think a bunch of my notes are under my bed. Not a good place for them to be when you're studying in class. All right, so make sure they're organized and try to get them all in one binder. They should fit as long as you got that big binder I told you to get. All right, guys, have a wonderful, wonderful Wednesday. Cam, we'll take care of the homework next time. Next time we check homeworks. It's fine. Or we can do it right now.